Hello, and welcome to the Pure Example video lecture. My name is Jeffrey Herman, and I'll be discussing the concept of don't cares. To begin, I will discuss some concepts I would have discussed in previous lectures. For example, this box here is something we call a K-map. And on a K-map, we have input variables, P and N. The input variables can take on values of 0 or 1, 0 being low voltage and 1 being high voltage, and then the outputs will appear in each of these four boxes. And they will correspond to different input combinations. So if P is 0 and N is 0, it'll output here. If P is 1 and N is 0, the output will appear here. Now, a don't care is a design tool that we use to help us when we know that certain input combinations are not allowed. So if 0, 0 was not allowed, we would put a don't care here. And to further explain this concept, I'll be using an example. In this problem, I'll be using the menu example where we have noodles and pasta, originally part of the program or the circuit that we designed to create a menu circuit. And if you know anything about noodles or pasta, you know that they're the same thing. So we shouldn't actually need both variables. So let's combine N and P into a new variable M. So I've already drawn my K-map here, and we're going to be solving for M. So when we don't have noodles, and we don't have pasta, which is this square here, we know that M is going to be 0 because there's neither noodles nor pasta. And then when we have pasta and we have noodles, we know that M is going to be 1 because when we have noodles, we should have pasta. But what about the situation when we have no noodles and we have pasta? Well, to be honest, this is an impossibility. If people are entering things into the system right, they should say it should have noodles and pasta at the same time, or should have neither. So we can say on both this one here, pasta without noodles, or noodles without pasta, that we don't care. Now we represent don't care with an X, and that means that this is an impossibility, that the circuit will never see this input, and therefore, since we'll never see this input, we don't care what the circuit will do when it receives that set of inputs. Now, the question is, how do we want to implement M? And the thing is, since we don't expect to see either of these, we can treat them as a 0 or a 1. Now, if we treat this as a 1, this one here is a 1, using our normal Boolean simplification, we can say this will be a 1 and a 1, so M will be equal to P. So this one will say M is equal to P. Now let's suppose we say, but now we're assuming that this is a 0 in that situation. Next case, we could also say, let's assume this is a 1 and this is a 0. And so in this situation, we could also highlight this one and simplify this to be M is equal to N. And so what we see is the don't care gives us flexibility in simplifying our equations, because if we don't ever expect to see certain behaviors, we can keep them from ever becoming an issue and therefore simplify our circuits. Our next quiz will ask you some more questions about the don't care concept, and I'll see you on the other side.